Hello mathematicians. It is Friday, and yesterday we were not able to have class because I had no power because of Hurricane Zeta. So instead I am recording this video to show you what we would have gone over during class. I'll be doing a couple of short videos, hopefully pretty short, that will give you an idea of what we would have been doing. So make sure you take a look at all of those so that you understand everything that we'll be doing. So, the topic for today is quadratic functions and how to model with quadratic functions. And to begin with, take a look at this scenario where we have data about bottles of hand sanitizer sold at 3 stores. We've got store A sells hand sanitizer at $4 per bottle, store A is $4 per bottle, store B is $5 per bottle, and store C is $6 per bottle. And notice that we have records also for how many bottles were sold per week on average with each of these prices. So 31 bottles per week for store A, 29 bottles per week for store B, and 27 bottles per week for store C. So looking at this data, take a moment and see what you notice and see what you wonder. What kind of patterns do you notice? What kind of relationships do you notice? And then what kind of questions pop into your head that you could answer with this data? So take a moment and actually pause the video and write down on a sheet of paper in front of you some patterns you notice and some questions that you wonder that you could answer with this data. So take a moment to do that. Okay, welcome back. Let's get started. So right off the bat, I see some patterns in the numbers in this table. So notice that store A, store B, store C, as we're going down this table, the price that we're charging for our hand sanitizer is going up by $1 per bottle. So that's an interesting pattern. And then there's another pattern as well. Every time that the price goes up by $1, fewer people want to buy it on average. So as the price goes up by $1, the number of people buying it goes down by 2 people. So that's interesting. Now another thing you might want to know is, well, how much revenue does the store make? Where revenue, by the way, the difference between revenue and profit, because sometimes that comes up with this sort of thing. Revenue is just how much money you bring in at all. Profit is when you then subtract out any costs that you would have had. So we're just focusing on revenue because that's all we have information for. So let's see. The revenue for store A would be $4 per bottle times 31 bottles. So that would give us a revenue of $124. Then store B would be $5 per bottle times 29 bottles per week. So that's now going to be $145. And then store C, $6 per bottle times 27 bottles per week. That would be 162. So $162. Now, you could also try to see if there's a pattern with these numbers. And there is actually an interesting pattern you can find, although it's not as obvious right now. It will be more obvious if you come back to the prices afterward. You'll see a very nice pattern potentially. But anyway, the thing to notice at this point is that as we raise the price, yes, fewer people buy it, but somehow the price is compensating for that, and the store is still able to make more and more money. So any business owner would want to know, okay, what would be the best price for me to set things at so that I can make the most money, if that's your goal. So what we could do is we could just continue the pattern. We could say, okay, well, what if we sell it at $7 per bottle? If we sell it $7 per bottle, we might predict that 25 people will buy it. And if you multiply that out, you'll find that the revenue ends up being $175. Okay, let's keep going. How about if we do $8 per bottle? $8 per bottle at 23 bottles per week. That will give us 184. of revenue. Okay, let's keep going. How about if we sold it at $9 per bottle? $9 per bottle, we'll sell 21 bottles per week if we keep going with this pattern, and then we will sell $189 worth overall. Keep it going. $10 per bottle, and now at 19 bottles per week, that'll give us a revenue of $190. And so things are kind of starting to taper off a little bit. Let's go one more. Let's say we sell it at $11 per bottle. Then $11 per bottle, that means we would expect to sell 17 bottles per week. And now that's only going to give us $187 in revenue. So it seems like right now our best option would be to sell it at $10 per week, because then we'll make $19, or we'll get 19 people to buy it per week, and we'll make a total of $190. But could we do better? Because we only tested whole numbers. So it would be really nice if we could really make sure that we have the exact best price. Maybe selling it with some dollars and cents would give us a better price. So, in order to do that, we can construct a quadratic function that describes what's happening. So, let's have R be our revenue. And we're going to define X in a little bit of a funny way. We're going to say that X is the number of dollars increase past $4. So what that means is that if we're right at $4, X will be 0. If we're right at $5, X will be 1, because that's $1 past 4. If we're at $6 for our price, X will be 2, because that's $2 past 4. And you'll see why it's useful to define it that way just now. So let's see. So the way that we calculated revenue, now if you're unsure about how to come up with an algebraic formula like this, what you can do is you can look at what you did with your numbers and then figure out how to do that in general. So it looks like we always multiplied our price per bottle times the number of people buying it. So the price per bottle, well, when it was $4, the number of people that bought it was 31. But then, when we increased our amount that when we increased the price of our hand sanitizer, when we increased it by $1, the number of people who bought it went down by $2 each time. So this will give us an idea of our revenue at any given price point. Notice that if we let x equal 1, then we'll have 4 plus 1 will be 5, and 31 minus 2 will be 29, which is exactly what we expected from our table so far. So let's just make sure I have what each of these is. This is the price per bottle, and then this is the bottles sold per week. And so if we multiply those together, we end up getting the price, or the amount of money that we make per week. So this is a quadratic function. And to see why it's a quadratic function, we can go ahead and multiply this out. So let's see. We'll do 4 plus x, and we'll multiply that by 31 minus 2x. And let's see what we get. 31 times 4 is going to be 124. We did that earlier. 4 times negative 2x is negative 8x. 31 times x is 31x. And x times negative 2x is going to be negative 2x squared. So another way to look at this would be negative 2x squared. Let's see, 31 minus 8, that's going to be plus 23x, and then plus 124. Okay, so that is a quadratic equation that describes our revenue as a function of how much we raise our price by. Now, a quadratic function, we're going to go into this more in the next video, but quadratic functions are always going to be shaped like parabolas. either opening upward or opening downward. And the leading coefficient, notice, is -2. So that means that we're actually going to be opening downward. So what we can find is the highest point, the maximum, will be the vertex of the parabola. And so if we can find that highest point, we'll know what the best price for our hand sanitizer should be. Now we could go ahead, you could graph this right now, but let's take advantage of some of the shape of a parabola in order to get an idea of how this works. Notice that parabolas are nicely symmetric. So if we can take advantage of the symmetry, then we'll be able to find our maximum price. Now to do that, let's think about what the worst prices to set would be. What prices could we set that would make us no money at all? Well, the first thing we could do would be to set our price to $0, because if we set our price at $0, we're not going to make any money. We're just giving away the hand sanitizer for free. So that would mean that the price would be 0, which means we would have to set x to -4. So if we did that, we would have r of -4 is going to be equal to 4 plus -4 times 31 minus 2 times -4, and that's going to be 0. The other possibility for what would make us no money is if somehow we managed to set our price so high that nobody wanted to buy it. And that would mean that we would be selling no bottles per week. We would have no customers. So how could we make that equal to 0? Well, if 31 minus 2x is equal to 0, then x would have to be 31 divided by 2, which is 15.5. So r of 15.5 would be equal to 4 plus 15.5. That means we'd be selling it at $19.50 per bottle. Yeah, of course nobody's going to pay that. Times 31 minus 2 times 15.5. This bit here is going to be 0, so the whole thing comes out to 0. Just like when this thing was 0, the whole thing came out to 0. So we have our two worst prices to set it at. Now if we use that, we could go ahead and graph our parabola so far. And our parabola is going to look something like this, roughly. And so what we found is that at -4, the parabola hits the x-axis because we're making $0. And at positive 15.5, we're also making $0. Now what we're looking for is the highest point on this parabola. And by symmetry, it seems like that highest point is right smack dab in the middle between those two x-intercepts. So if we could find that point, we would have our best possible price. So if we go ahead and do that, the way to find out the number right smack dab in the middle between two numbers is to find their average. So -4 plus 15.5, divide that by 2, and we're going to get, let's see, a -11.5 divided by 2. That's going to be -5.75. So that is this point right here. So, hold on. That should not have been negative. Derp. So that really should have been just 11.5 and 5.75. And as soon as we graphed it, we saw that there was something wrong. So, let's see. So now we know the best price to set things to. If we plug this in here, 5.75, that's going to give us that the price per bottle should be $9.75. Congratulations, this is how price gouging happens. Now what would actually be that price? Well, it turns out that if you go on over to Desmos, you could plug things in and you could see that it would be $190 and 12.5 cents. So that's telling us that R of 5.75 is going to be $190 and 12.5 cents, but we'll call it 13 cents. So that is this point up here, 190, 13. And if you want, you could even go ahead and graph this whole function in Desmos. Now that we've seen it, we can say r of x equals 4 plus x times 31 minus 2x. And if we zoom out, we're going to have to zoom out a whole bunch in order to see it. There we go. But we could click this point up here at the top, and there we go. Our best price is $5.75, increased from 4, so $9.75 total. And then our revenue that we end up with is $190.13. And that right there is an example of how to use a quadratic function to model a real-life situation. Profit and revenue, those kinds of things are often analyzed with quadratic functions. There's a number of other possible things, but often what you find yourself trying to do is what's called optimization, which is just trying to find the maximum or minimum value of your function in order to solve some kind of real-world problem, like maximizing your profit or minimizing your cost or energy consumption or things like that. Okay, so that's the end of the first video. In the next video, we'll take a look at the anatomy of a parabola and how to write it in different forms to get an idea of different aspects of the parabola. So I will see you there.